Hello, everyone. Thanks so much for joining the BlockDataPy Summit. We are just kickstarting it with the first session of the day, which is blending art and science to identify actionable drivers of shrink in stores. Our speaker is Priyanka Khare, who is a data science manager in the Home Depot. And a little bit about Priyanka. Priyanka is a data science manager at the Home Depot, and she is passionate about helping the business make data driven decisions and is currently working with the store operations team to minimize inventory shrinkage across the company's 2,000 plus stores. She has over 11 years of experience in data science, analytics, and reporting. During her free time, she loves spending time with her husband and two boys and enjoys road trips, hiking, and trying new restaurants. Priyanka, over to you. Would you like to kick this off for us?
Sure, thanks, Zareen. Good morning, everyone. So happy to be here talking to this amazing group this morning. This is my first time speaking at a Women Who Code event, so that makes this even more special. So I'm Priyanka Khare. I'm a data science manager at the Home Depot. And in my current role, as Zareen mentioned, I support Home Depot's operations teams with data and analysis needs needed to reduce inventory shrinkage in our stores. So, for those of you that are not familiar with inventory shrinkage or shrink, as it's commonly referred to, this occurs when your actual inventory on hand is less than what is recorded in your books. So today I'm going to talk about a recent project that our team worked on where we blended the art and science to identify actionable drivers of shrink in our stores. So a little bit about myself. I have 11 years of total experience. The last 7 of those have been at the Home Depot, where I've had various roles in data architecture, analytics platforms, business intelligence, reporting and analytics, and data science. Now, for those of you in North America, Home Depot is probably a familiar name. We are the world's largest home improvement retailer. Our sales crossed $150 billion in 2021. And we've grown significantly over the past few years. We added $40 billion to our top line just in the last couple of years. We have a footprint in North America with over 2,300 stores across the United States, Canada, and Mexico. We employ over 500,000 associates. And the United States is the largest market for the company with over 2,000 stores. Now, an average Home Depot store is about 105,000 square feet. And with hundreds and thousands of SKUs per store, the scale at which we operate is pretty massive. So, with that background, let me jump right in and first talk about the problem that we were trying to solve here. Now, shrink in stores is a growing problem for the retail industry. The National Retail Federation pegged that number at 1.62% of net income in 2020, which is a significant $62 billion. Now, shrink can occur due to a variety of reasons. Some are malicious, such as theft or fraud. So you may have heard in the news more recently where stores are being targeted. So a Home Depot store and a Nordstrom store in California were targeted earlier this year. And then more recently, an Ulta store in Michigan was targeted as well. And this is a huge problem for the industry. Not only does it result in loss in terms of shrink, it also threatens the life and safety of retail workers and customers that shop there. And overall, it's just a bad experience for everyone involved. Now, unfortunately, malicious activity is a function of the surrounding area of the store and it's not always controllable by stores. Other drivers are operational, which can cause shrink if processes are not followed as they're intended. So consider this example. A customer goes on homedepot.com and orders some ceramic potters that they want to pick up in the store. So the store associate goes, retrieves the potters from the shelf, and then they place them in the staging area for all store pickup orders. But the customer never shows up to pick up their order, nor do they cancel the order. The potters stay in the staging area for a few days, and eventually they either get lost or damaged, which results in shrink. But perhaps a worse consequence of this is that of a lost sale. So while the potters were sitting in the staging area, a customer that actually wanted to purchase them could not purchase them. So so unlike malicious drivers, these operational drivers, some of them are store controllable. So if processes are followed the way they should be, then we can actually prevent shrink from occurring. Now, for the Home Depot, just like the rest of the industry, shrink is a growing problem. However, in order to solve it, our leaders needed the visibility into what was driving shrink and which of these drivers was store controllable, and then subsequently determine what action needed to be taken. So pausing just before we move on, let me talk you through some of the terms that you've just heard. So I'll reiterate them, and then also some things that you might hear in subsequent slides. So shrink, like I said, occurs when your actual inventory on hand is less than what you should have based on your books. So your records say you should have 10 units of an item, but physically when you count it, there's 9. So that 1 unit that's missing is considered a shrink. Now, if the Home Depot with 2,000 stores and hundreds of thousands of SKUs per store, counting each and every SKU is a very daunting task, and we cannot do that very often. So more often than not, a store will undergo a physical count once a year. So that gives us one data point a year per store for shrink. Shrink can have operational drivers, which are process driven or malicious reasons, such as theft. Another term you just heard is SKU, which is stock keeping unit, which is a unique item identifier. And then lastly, SME or SMEs are subject matter experts, and in this case, in the area of shrink. Okay, walking through the process, I'm going to, as I do that, I'm also going to talk through the technology that we use at this stage. And this is important because having a technology stack that is able to handle the data volumes, scale up and down as you need it to, and then also processing our analysis in a timely and cost effective manner is critical to our success. So the first step was defining the problem and scoping it. So here we set out to identify the most influential store controllable operational drivers and malicious drivers that explain shrink. Next up was figuring out what features we wanted to put through the model. So here we tapped into our feature repository that has hundreds of potential shrink drivers. So some of these are operational, like vendor credits. Some of these are malicious, like theft cases. Some of these are control variables, like store location or count of competitor stores in the area. This repository has been built in Google BigQuery, and it has data from various sources, be it our store systems, our ordering systems, or our third-party vendor data. The metrics in the repository are updated weekly, and this is tapped into for most of the projects that the team works on that are related to shrink. Now, for this specific analysis, most of the features we selected already existed in the repository. There were a few additional drivers that needed to be added, and we were able to easily do that. As well as there were some drivers that needed a different variations. For example, we may have had dollars for a certain feature, but we needed rate. So we were able to quickly make those modifications. Now that we had a feature set, next up was model development. So for modeling, we used Google's Vertex AI, which is essentially Jupyter Notebooks that runs on a virtual server in the cloud. For the modeling components, we used Python, and then we used BigQuery to stage our input data as well as the model outputs. Now, the goal here was to understand what drivers of shrink were. So explainability was the primary concern, and we were less focused on accuracy. So we used a regression model as it provided the best insight into what drivers correlated with shrink. We went through multiple model iterations. So initially we built a baseline model, which was then used to benchmark and compare subsequent models. We also built models with all variables, operational, malicious, control variables. And this was done to understand everything that contributed to shrink. And then we also ran models with operational only variables or malicious only variables. And this was done, to understand, for example, an operational model with operational variables only would be able to pick up on operational drivers that would otherwise have been hidden by malicious variables that were more strongly related to shrink, and vice versa. Now, in doing so, we brought our business partners along with us on the modeling journey, and we kept them updated on the various model outputs and the variables that we were seeing as significant in the model. And they in turn helped us, think through why certain things were popping and why some of the relationships with shrink we were seeing were the way they were. So, for example, in one of our models, external theft cases was showing up as a negative correlation with shrink, and that's a little counterintuitive if you think about it. If you have more theft in the area surrounding the store, you would expect that your shrink would go up. But the way the business partner explained it is that if you know that there is more theft in the surrounding areas, you would likely be doing something about it, and that's why the shrink would come down. So this was the type of back and forth we would have with them, through the multiple iterations. So we finally landed on a set of operational and malicious drivers that we felt good about from a modeling standpoint. So next up, we then took that list, worked with our business partners and field SMEs to further add the actionability lens on it. So the goal was to identify operational drivers that were truly store controllable and where we could identify a clear action for the stores to undertake. So when we looked at it from that lens, some of the variables were weeded out further. So, for example, items that are lost in transfers between one facility to another, it's not something that a store can control. It's controllable by the company, but not by the store. So, applying that lens, we said, okay, we need to drop this variable from the final list. Additionally, in discussions with the business partners, there were a couple of variables that were not picked up by the model as significant, but the business partners felt very strongly about it, and they were pretty clear on what action needed to be taken there to mitigate shrink. So we ended up adding those two variables into the final list as well. And while doing so, we were cognizant of how many drivers would make the final list. We didn't want too many because the stores would be inundated with things to do. But then, of course, we didn't want too few drivers as well. We had similar discussions on the malicious drivers, and while malicious drivers are not typically store controllable, we did ensure that our field SMEs felt good about the drivers that we finally picked. So, with our final set of drivers, next up was providing visibility into the drivers to the stores and communicating with them on what action they needed to take. So, we made the drivers available in our store reporting applications. And we also came up with a store execution score that would allow us to track how the stores were performing with each driver. So, if a store was doing well, we would expect that their execution score would go up over time. And all the driver data as well as the execution scores were staged in Google BigQuery, and we used Tableau for analyzing store distributions as we were developing the execution store. So a little more on the execution score that was developed. When we looked at how that was distributed across our stores, and this is the chart on the left, we saw a normal bell curve, which was expected, with a slightly longer tail on the stores that were lower performing. So these are the stores that you see highlighted in the blue box. So these stores represented our opportunity to take immediate action on the drivers. Next, we looked at how our execution score was correlated with shrink rate. So if you look at the chart on the right, as our execution score increased from 10% to 100%, the shrink rate, which is represented by the blue bars, decreases. So this gave us the validation that we needed, that the drivers we had picked and the execution score that we had designed would take us in the right direction. So this process is a really good example of blending art and science to solve a problem. We built a model, we identified the drivers that were significantly correlated with shrink, and then applied an operations lens on it to pick the drivers that stores could control. We provided visibility to the stores on the needed action on these drivers and designed an execution score that would allow us to track their performance over time. We did this by bringing our business partners and field leaders along with us on the journey, and the end result was better and more actionable. Including them in the process early on ensured they were aligned and more vested in the success of the project. Now, the project rolled out successfully and it was received well in the field. But, thinking back, everything was not hunky dory. So, I'd like to wrap this up by talking through what we learned from this project. And hopefully, some of you will find this helpful in your current or future projects. So, thinking back, there were some things that worked well for us and others that could have gone better. So, one of the things that was a major factor in the success of the project was that this project had alignment at the executive level, that this was important and the right thing to do for the company. And that helped us in a couple of ways. One, it ensured that all the teams that were involved in the project knew what the priority was, and we were all marching towards the common goal. And two, since the priority was clear, any other ask that competed with resources with this project, we could easily say no to. The next thing I want to call is that collaboration really worked well between the teams. And part of this was because everyone was aligned on priority. But really, the teams did work well with each other. We all had well defined roles. And specifically for us, the fact that we engaged our partners early on and involved them in the driver selection process really had them vested in the success of the project. Next, what worked was just following some project management basics. So once we had determined what the scope of the project was, we tried our best not to stray from that. And this is not to say that things didn't come up or they weren't enhancement opportunities identified. They were, but we were very focused on getting a version one out, and we parked any future enhancements for a version two. Um, So we had regular stand-ups with our teams as well as business partners to make sure that we were, making sure that things were moving along and we were addressing any blockers in a timely manner. Another thing that I'd like to talk about that helped us hit the ground running was our data and analytics infrastructure. So I talked about our shrink repository of potential drivers that was already available and easy to add to and modify. We use this for most of our shrink projects, and we were able to leverage it for this drivers analysis as well. We also have multiple environments already set up that allow us to run multiple projects in parallel, and this makes sure that the team doesn't step on each other's toes. The other thing I'm going to call out is that we have a well-defined enterprise. We have well-defined enterprise tools and technologies that are supported by our IT teams for data engineering, developing models, scheduling, and visualization. And these work for the scale that we need. So there was no time lost in choosing the right technology or having to build out features from scratch. Next, I want to talk about, thinking through when we were trying to solve for how we want to approach this problem. We discovered that we were able to draw from, methodologies that we had used on previous projects. So we had done drivers analysis in the past, we had built scoring models in the past. And even though we may not have solved the exact problem, they were similar enough that we could reuse components from them. And this is important to keep in mind, especially for those of you that are, perhaps newer in your careers, that you don't always have to reinvent the wheel, right? You can always draw from something that someone somewhere has worked on and use that, and that helps you move a little faster. And then finally, most of us have been in the situation where we've had to explain something technical to a non-technical audience. And in this case, we were partnering with field leaders. They're world-class operators. They know, from experience how operational processes cause shrink. But they don't really understand regression models, nor do they care, how many iterations we ran or what the R square was. So when we would meet with them to review drivers, keeping it simple really helped. So, we would talk to them about, well, these were the drivers that are showing up, how they were related with shrink, and then talk through the business process and try to discuss with them, why or why not it was showing up in the model. And this they understood, right? We were speaking their language. They were able to partake in the conversation, and we kept moving forward. Now, that was everything that worked well. There are some things that could have gone better. So initially, cross team collaboration was off to a slow start, but then once everyone was aligned that this was the number one priority, we moved full steam ahead. And finally, we rolled the drivers out in such a short period of time. The team wished that they had more time to validate the data and the metrics prior to launch. So with that, I'm going to open it up to any questions that anyone may have.
Amazing. Thanks so much, Priyanka, for this super interesting talk. I personally really enjoyed it. I'm looking in the chat. Please, any of you, if any of you have any question for Priyanka or about her presentation, please just type it in the chat so that we can take it. And in the meantime, maybe Priyanka, I have one question. So you mentioned that the team didn't have enough time to do like enough validation before the product was launched. I was wondering, like after it was launched, was there a way to get feedback after it's live from the uh, real users? Did you like try to
Yeah,
validate?
yeah. So at Home Depot, if something goes wrong, people will make sure that you hear about it. So for the folks in the field that had questions, they certainly reached out and let us know if they felt something didn't line up with the way they expected it to. But we also proactively reached out to field leaders to understand how the metrics were being received in the stores. And for the most part, it was positive. I think the biggest call out was that this was the first time that they had the level of visibility they needed to actually action on shrink drivers, which was very heartening to hear. And then, of course, they had some pieces of feedback on how we could improve the process going forward. But yes, both solicited and unsolicited feedback was provided.
That's great. I'm sure that has been super helpful for your team.
Absolutely, yes. I mean, nothing better than getting feedback to kind of improve on what you have out there.
Amazing. We have another question from Catherine. The question is, have you been able to quantify any impact from the model yet?
Yeah, so that's something we're looking into currently is to see for the drivers that we picked, how would you, like, what is their dollar contribution to shrink? And of course, there's some things to keep in mind. I mean, one, we did kind of pick certain drivers that we knew were actionable. So it's not that we're taking all the factors that we believe impact shrink and then coming up with a shrink prediction. It's a subset of the values. So dollar prediction is a little, um, I would say it's not straightforward in that sense. But that's something we're working through right now. And yeah, trying to figure out what's the best way to do that.
Great. We will take one last question from Maria. The question is, how do you make sure you communicate that correlation doesn't always equal causation?
Yeah, so in talking with our business partners, that did come up a lot, and specifically around a lot of those control variables would show up, and you'd be like, hey, why does the store location have anything to do with sort of shrink? And you talk about these are things that are indicators of shrink. So there's something happening, while these variables are showing going up and down that indicate there is shrink happening, and it's not always causality. And this is where the discussions with the business partners really helped, and thinking through what was the process and could it really be directly causing shrink or just indicating that shrink might be happening. So for example, one of the kind of drivers, which is an important indicator of shrink, is on-hand adjustment. So this basically means that when when you discover that you have shrink, you typically will adjust your on-hands to say that no, I don't have 10 like my system says, I actually have 9, so I'm going to adjust it down by 9. So you're adjusting it down because there is shrink, and that's really an indicator of shrink. It's not what is causing shrink, right? But it's indicating that there is a problem, and that's why you're having to adjust things down. So just talking through the business process really helped us determine whether it was an indicator or whether there was actual causality over there.
I hope that answers your question, Maria. Well, thanks so much, Priyanka, for sharing the presentation with us today. I'm sure our audience really loved it. And thanks so much for presenting. I hope you enjoy the rest of the conference.
Thank you, Zareen. Thank you, everyone. Bye.